Hello everyone. Today we're going to be going through some new vocabulary to go along with our new unit. So if you can take down some notes while we go through this. All right. New vocab for space figures, three-dimensional figures, also called polyhedrons. So they're all fancy names given to any really three-dimensional shape. So for polyhedron, that's our first vocab term. Polyhedron is a three-dimensional shape. 3D figure whose surfaces are polygons. So we already did a unit on polygons. So all of that info from that unit, all of that vocabulary is all coming back here. We have another term that's called the face. So for each polygon has a face that is going to be a polygon. So any one of the sides really is another way of saying a face. So the sides, we can call it, of a polyhedron. So if we look at the shape here to the right, that's called a rectangular prism. That's one example of a polyhedron. If we count up all the sides of that shape, we would see that we had 6. We have the left and the right, if you will, top and bottom, front and back. So that would be 6 faces to that shape. So the edge. An edge is a segment that's formed by the intersection of 2 faces. So is a segment that is formed by the intersection of 2 faces. So we haven't talked about intersections in a while, but intersections, so any place where the 2 faces connect to each other. So along this, say this line here, this segment, that would be considered an edge of your shape. Same idea down here where the front, if you will, and the bottom meet each other, that line segment there, that intersection is considered an edge of the shape. A vertex. A vertex is a point where 3 or more edges intersect. So a point where 3 or more edges intersect. So any one of these little corners, if you will, of our shape here. So like right here, that would be considered a vertex. Here's a vertex. In the back, here's another vertex. And then there's one up here as well. All right, so it's a point where 3 or more of our edges are going to intersect each other. And then a net is a 2-dimensional version of a 3D shape. So a 2D version of a 3D shape. So that's kind of a loose definition, but really what you're looking at down here is considered to be now a net of the same rectangular prism that's up here. So if we pictured taking this shape here and then we would fold up the edges, we would be getting the box or the polyhedron that's up here. So same concept, you could think about it in reverse. If you ever have taken a box and you cut along each one of those edges and unwrapped it, so to speak, you would get a shape that looks something like this. And there's different variations of a net. This is just one of them. But it's an idea of looking at the shape in its 2-dimensional sense. Everything we've done so far this year has all been on 2D shapes. So since that's something we're more familiar with, if you want to, as we go through this unit, try to think about the net version of any one of the 3D shapes, that might help you to calculate any of the surface area or volumes that we're going to be working with. So that wasn't enough vocab, right? So we have a couple more. So if we're going to be talking about a right prism versus an oblique prism. So a right prism is your general prisms. It's the ones that go straight up and down. So this here is a right prism. We see that we have a right angle in it. Same idea. This prism is a right angle, has a right angle down here. So it's a right rectangular prism. Here's a right pentagonal prism. You could picture a little right angle in here. So we know that the sides of the shape are going to be perpendicular to the base, versus if we look at an oblique prism, it's really just tilted. That's our Leaning Tower of Pisa. It's just tilted over on its sides. So we don't have that right angle going from the side to the base any longer. So a right prism, the sides and the bases are perpendicular. versus an oblique prism then is just going to be the sides and the base are not perpendicular. Lateral faces. So the lateral faces are the faces that go around the base of the shape. That doesn't probably make like any sense, right? So if we're looking at this, this is called a triangular prism here. The name of the prism is based off of the shape of the base. So the base here being this triangle, this right triangle here, side length of 3, side length of 4. So that is considered our base. So that means we have another base back here. This other triangle would be considered a base. So anything that connects the two bases together, any of those 3 other sides here, are going to be considered the lateral faces. So it's the faces that connect the bases. Polyhedron. All right, so then the base, that's how we name a polyhedron. And then we could put with this the example that over to the right we have a triangular prism. Therefore, the base is a triangle. Down below, we have that right pentagonal prism. And that's because the base is a pentagon. Base is a pentagon. All right. So let's take a look then at our next vocab term, altitude. So altitude, we've used that before. We've talked a lot about triangles and drawing in the altitude, right? That was one of our special segments and shapes. Even as we went through the last part of our trigonometry unit, we talked about trying to find the altitude of different triangles, again, using trigonometry. So it's going to be the same kind of concept here. Our altitude is always going to be our perpendicular height. Right, so if we see here on this oblique prism, our altitude is going to be this red line here. It has to be perpendicular to whatever the base is. So if it's going to be an oblique prism, the height or the altitude is going to be outside of the shape. Versus if we're looking at, say, this right rectangular prism here, that height is labeled h here. It's straight up and down. Same idea, the height is labeled here, or altitude. Okay, and then over here, our height, well, we have to see what we're talking about. Is it the height of the prism or is it the height of the base? Because the height of the base is 3, or it could be 4. Either way you're looking at it. That would be considered our height of the base, but then the height of the prism is 6. So we have to be very careful. Make sure you know what you're looking for within a problem. Are you looking for the height of the base or the height of the prism? All right, so it's the altitude, perpendicular height of the polyhedron. If we're talking about height, there is what's called, if we go down here, we have slant height. So if we're looking at the oblique prism here, what's on the slant, that length there, that would be considered the slanted height. So it's a diagonal height versus we have height of a prism, which is the distance between the bases. And then we have height of a base, which is depending on your shape. The example was 3 or 4 from the triangular prism up above. So it's just height like you are used to finding. So 3 meters or 4 meters from triangular prism example above. So totally depends on your shape. You got to look at what you have and see if you can be able to identify the height in question. Last piece, this is what we're going to start working on next class, lateral area versus surface area. So if I ask you to find the surface area of the shape, I'll do that one first. That's asking you to calculate everything, the area. So think about gift wrapping or painting. Any shape that we're talking about, we want to know how much surface area do we have to cover. So how much area is the sum of all the faces. So sum of area of every face. Versus lateral area is just going to be the sum of the faces going around the bases. So we're not talking about the top and the bottom bases. We don't want to cover those. We just want to cover the edges around it. Okay, so it is the area, sum of the area around the bases. Okay, not including them, just going around them. So if we're looking at that right pentagonal prism example here, the lateral area would be all this white stuff, right, going around the bases, because the base is the pentagon here and here. We don't want to calculate the area of that. We just want to calculate the lateral area, the area of the 5 rectangles that are going around the pentagon, that are connecting the base to the base. So these are just some loose definitions, some vocabulary for you to look at, just something for you to refer to. At our next unit, we're going to be going over, or at our next lesson, I should say, we're going to be going over specifically for each one of the shapes, how do you calculate lateral area and surface area. Thank you for watching.